Students, this is the first in a series of common skills videos for both of my students in calculus and in pre-calc honors. The LCD is referred to a lot. It's the least common denominator. Least common denominator. And we're going to use it for adding fractions, getting fractions out of equations, and simplifying compound fractions. That's fractions where you have fractions within fractions. Okay? Here's our first skill, adding fractions. You've seen this many times before. But if we see something like 1 over x plus 1 over x minus 2, there's no equal sign here. You're just coming up with the expression, so you have to get these both over a common denominator. So in this case, we use an LCD equal to x times x minus 2. I like to put a flag on it, and the special base in this case is the plus sign because we're adding up two fractions. Now, what do you do with the LCD? Well, you've got to get both fractions over the LCD, so we're going to multiply first fraction by x minus 2 over x minus 2. That makes it equivalent to what it was before. It's just changing the form. Second fraction we multiply by x over x. Now both fractions have an x times x minus 2 in the denominator. So now you can go ahead and add up. X minus 2 plus x over the LCD, or 2x minus 2 over the LCD. And now we might want to factor this 2 times the quantity x minus 1 over the LCD, which is x times x minus 2. We see that there's no common factors, so that's fully reduced, and that's our final answer. Okay, so that's adding fractions. Now, what if you're trying to get rid of fractions in an equation? Like 1 over x plus 1 over x minus 2 equals, let's say, equals 4/3. Our LCD is a little different this time because we have fractions on both sides of the equation. So the LCD will equal 3x times x minus 2. Now, we use the LCD differently here. It is not necessary to add up the fractions on this side and add the fraction on this side and cross multiply or anything like that. We can get rid of the fractions in one fell swoop. And we didn't do that last time because we're adding up the fractions and the final answer was a fraction. But now we can use the LCD to get rid of fractions in an equation. So I use this special symbol to represent that I'm using it in a different way. I'm using it to get rid of fractions. So we have 1 over x plus 1 over x minus 2 equals 4/3. And we multiply both sides by that LCD. So this entire side gets multiplied by the LCD, and this whole side gets multiplied by the LCD. So this gets distributed, and when we distribute it, the LCD will cancel out anything underneath. Focus on that first. So here in this first case, the 1 over x cancels with the x, and we just left with 3 times x minus 2. Plus, in this case, the x minus 2 cancels, so we're just left with 3x. On the right side, the 3 will cancel with the 3 in here, and you're left with 4x times x minus 2. So in one step, you have no more fractions to deal with. Now let's continue on with the problem by getting rid of the grouping symbols. 3x minus 6 plus 3x equals 4x squared minus 8x. So let's see, we get 6x minus 6 equals 4x squared minus 8x. So 4x squared minus 14x plus 6 equals 0. It's going to help to factor out a 2 there. So 2x squared minus 7x plus 3 equals 0. And I believe this factors. Let's try around a few numbers here. 2x times x, that's the only choice you have in that. And if we go 3 and 1 in this direction, we're going to have 1x and 6x to make 7. So we have to make them both minus. So we get our two answers of x equals a half, or x equals 3. Now be careful. Do check to make sure you're not dividing by 0. Check. Don't divide by 0. So if either of these make a denominator equal to 0 in the original equation, we can't keep them. Nope, they don't. Third and 1 is 4/3. If we put in a half, we get 2 plus negative 2/3 is 4/3. Yeah, that checks out too. So we do get two answers. Finally, we have simplifying compound fractions. And this is when you have fractions within fractions. So let's say we have something like 1 over x plus 2 plus 1 over x minus 2 all over 1 over x minus 2 plus 1 over x. This could be a big bear, adding and subtracting these two fractions and so forth. So what we're going to do here with simplifying compound fractions is I use an LCD equal to the least common denominator of all the denominators. So that's x times x minus 2 times x plus 2. Put in a flag, and I put a special symbol down here now, not the equal of the addition, but the idea of the fractions within fractions. As you see here, you got fractions within a bigger fraction. And now the trick here is to multiply both numerator and denominator by the LCD. Here's our original problem again, and now we're going to multiply both the numerator and denominator by the LCD. And it's the overall LCD of both numerator and denominator. So x times x minus 2 times x plus 2 all over x times x minus 2 times x plus 2. Let's see what happens now. Should get rid of all these secondary fractions. I mean, the whole thing is still going to be a fraction. You can't avoid that. But it's going to get rid of all the secondary fractions. So in this case, the x plus 2's cancel. We're going to be distributing this over both these, recall, here and here. And this is going to get distributed over both these as well. So in the numerator, the x plus 2's cancel, and we're left with x times x minus 2. Here, the x minus 2's cancel, so we're left with x times x plus 2. All over. Distributing this into here, we cancel out the x minus 2, so we have x times x plus 2. Plus, and now the x is canceled, x minus 2 times x plus 2. Now be careful here. This might be tempting to cancel some x plus 2's here, but you cannot. This x plus 2 is not really a factor of the whole numerator. We're going to have to expand this all out, maybe refactor, see if anything cancels out. So you have x squared minus 2x plus x squared plus 2x all over x squared plus 2x plus x squared minus 4. Doing that conjugate multiplication there. So in the numerator, we just end up with 2x squared. In the denominator, 2x squared plus 2x minus 4. Now, about all I can see they can take out of here is a 2 of the numerator and the denominator to get x squared over x squared plus x minus 2. This might factor on the bottom, yeah, x plus 2 times x minus 1, but that doesn't help reduce it because you don't have that factor on top. So there's your final answer, x squared over x squared plus x minus 2. That's the three uses of the least common denominator. One thing to watch out for, though, is when you're doing an inequality. I didn't list it as a use. We have to be careful with something like this because we can't use the LCD to multiply both sides in this case because we don't know which direction this arrow will go. We don't know if the LCD is positive or negative. So be careful. The LCD being used to get rid of fractions on both sides of the equation works fine if it's an equation, but since this is an inequality, we have to just go back to adding up the left side. So you have x minus 1 plus x over LCD, so that's 2x minus 1 over x times x minus 1. And now you can go through and look at your factors chart to see how this works, to see when if it's positive and negative. The critical numbers are 0, 1, and a half, because those are the numbers that will make the whole expression equal to 0. They're not actually part of our solution. And now you could just test a point in each section. I'm going to do this by binomial factors. That is looking at 2x minus 1, x and x minus 1, and what happens with each of those as we go along the number line. The 2x minus 1 changes and it's 0 here at a half, so it's negative before that and positive afterwards. X changes at 0. It's negative before 0, positive after 0. X minus 1 changes that 1. It's negative beforehand, positive afterward. So when I put them all together, you get negative, negative times positive, negative is positive, positive times negative is negative, and 3 positive multiplied together make positive. So when is this thing negative? It's negative. When is it negative? It's negative here and here. So we're going to shade in less than 0 or between a half and 0. So there's your final answer. X is less than 0, or a half is less than X is less than 1. You can also use the interval notation on this. Negative infinity up to 0, 1/2 to 1. Flange out.